Significant quantities of metal-bearing waste are generated by the aerospace, automotive, printed circuit board and metal finishing sectors without recovery of valuable materials from the waste streams. Currently, this is destined for landfill, squandering natural resources and impacting negatively on the environment, as more materials need to be extracted to replace those thrown away. By combining the existing technologies of electrocoagulation, material digestion and electrowinning, the Ecometre project has developed a flexible metal recycling system, enabling the recovery of metal from waste streams across the metal finishing industry. The Ecometre partners have developed and built an initial industrial plant for a typical small business working in the metal finishing sector. These are currently under extreme financial and environmental pressure, both on raw material inputs and waste disposal, and have been identified as an important target market segment for this eco-innovation. The first installation is integrated into an electrolytic nickel plating line and is being used to treat wash waters with nickel contents as low as 40 parts per million. The waste effluents from the plating lines are collected and stored ready for reprocessing. The effluent is pumped through an electrocoagulation cell at a fixed rate, and aluminium is dosed into the solution as a flocculant. The electrocoagulation cell developed for the Ecometre project is capable of reprocessing 10 metres cubed of solution per week. The rate of aluminium dosing is controlled to maximise nickel recovery and minimise energy costs. After dosing, the flocculant is allowed to settle before the sludge is extracted using a filter press. This system allows for additional dewatering, with the remaining solution being suitable for disposal to drain. The filter cake collected has a high concentration of nickel and is therefore suitable for metal recovery on an economic scale in the second part of the process. After the sludge has been produced, it is transferred to the electrowinning equipment, where it is processed along with filter cake collected after previous runs. The electrowinning system has a capacity of 20 kilograms of filter cake in a single batch. The nickel-containing filter cake is transferred to the dissolution tank and sulfuric acid is added. Heating and agitation increase the dissolution rate to produce a concentrated nickel solution, but the aluminium it also contains must be removed to allow electrowinning. The aluminium is removed by controlled precipitation of aluminium hydroxide as a suspended solid, leaving the nickel in solution. The solution is then pumped through a bag filter to remove suspended solids and leave a solution that is suitable for electrowinning. If other methods of filter cake production are utilised, it is possible to adapt the process to recover the metals it contains. The bag filter will then be removed and the aluminium hydroxide either recovered for smelting or disposed of as a non-hazardous waste stream. The electro-winning cell used in the Ecometre project is a Chemelec system that uses a fluidized bed of ballotini to increase mass transfer at the cathode surface. This increases the window of operable solution concentrations and allows the recovery of metals with concentrations below 5 grams per litre. pH control of the solution prevents unwanted acidification and redissolution of recovered nickel, while control of the cathode current maintains an optimized current density on the electrodes to reduce salting or precipitation. The recovered nickel is suitable for re-entering the plating process as an anode, reducing the primary metal requirements for the operator. Ecometre provides an innovative route to metal recovery and material valorization. For more information, please visit our website or contact us. We will be happy to answer your questions or provide advice on tailored installations for your business.